This is the FV function, which stands for the future value function. We're going to use this function to evaluate two investments. We're going to evaluate a one-time investment, and then we're going to look at a retirement plan scenario where we're going to make investments on a recurring basis. I'm in the Data Analytics Project 4 workbook, and I'm in the Future Value Worksheet tab. Going to begin by clicking cell B5, and we're going to use the future value function to evaluate a one-time investment. We're going to invest, in this scenario, $7,500 over 10 years, and our expected rate of return is 5.5%. So I'm going to start by typing the equal sign. The function name is just FV. Open the parentheses, and you will see in the tip box the arguments that need to be defined for the future value function. The first argument, the rate argument, is the return rate, also known as the growth rate. I'm just going to click on cell B2. Our expected growth rate here is 5.5%. I'm going to type the comma. That advances me to the NPER, which is number of periods. This is how long the money will be invested. And in this scenario, we'll have our money invested for 10 years, which is in cell B3. So I'm clicking cell B3. Type a comma. This is the PMT, or payment argument. This is going to be used in the next scenario where we have an investment that keeps recurring on a monthly basis. Since this example is a one-time scenario, we're going to skip that argument by just typing another comma. An argument that's not defined will be assumed 0 by Excel. So we're just going to skip this and go to the PV, which stands for the present value argument. Now, similar to the payment function, when we were defining the PV argument, the payment function, this must begin with a minus sign. So when you're defining the PV, or present value argument, you begin with a minus sign, and this is going to be defined with the amount that we're investing. So we are investing $7,500, which is in cell B4. So I'm going to click B4. So note it's minus B4. So minus B4 is how we're going to define the PV argument. Typing a comma to get to the type argument. This is also like the payment function, where we have 0 would be making an investment at the end of the first year, or a 1 would be making an investment at the beginning of the first year. So we're going to set this to 1. So we're going to assume that we're going to make a one-time investment at the beginning of the first year, and our money will stay invested for 10 years. I'm going to type a closing parentheses and tap the Enter key. And the output is $12,811.08. And just like we've seen before, we can do some scenarios. So if I wanted to change the amount of time our money is invested, let's say in cell B3, I can change this to 11. And notice the value of our investment increases the longer our money stays invested. So if I keep changing the amount of time this investment stays in place, the output of the future value function keeps changing. And I can bring it back down to 10. And that brings the future value function to its original output. So that's what the future value function looks like when you're evaluating a one-time investment scenario. Dropping down to our second scenario, this is going to be a retirement scenario where money is going to be invested every month. So the total investment for every month is going to be $750. And in the textbook, we added a formula here so we can see the company match and the payroll deduction. So our total, there's a formula that's calculating the total monthly investment here. Going to click on cell B14, type an equal sign. The function name is FV for future value. So now we're going to set this up for a recurring investment scenario. The rate is going to be in cell B8 for this scenario, which is 4.5%. But I'm going to type the slash for division, and then I'm going to type the number 12. We're going to need a monthly rate of return since our investments are being added to this scenario every month. Going to type a comma. The NPER is the number of months in which my investment is going to take place. So this is going to be cell B9, and I'm going to multiply this by 12. So again, very similar to the example we saw with the payment function, the rate argument and the NPER arguments must be in comparable terms. So since we're dealing with a monthly investment scenario here, we're going to take the rate argument and set the rate of return to a monthly rate of return. And in the NPER, number of periods, this is going to be how long our money is going to be invested, but now in terms of months. I'm going to type a comma and go to the PMT argument. This is now the monthly payment. So I'm going to start this with a minus sign. So now we can see the PMT argument and the PV arguments must start with a minus sign first. And my monthly investment is right here in cell B12. So negative B12 is what the argument should look like for PMT. Type a comma to go to the PV. This is how much money is already invested. And we've taken a look at this before. Start with a minus sign. click cell B13. This is the current balance, so this is the money that's already invested. I'm going to assume that these investments or the monthly investments are going to take place at the end of every month, so I don't need to define the type argument. Excel will assume 0 if I do not define this. So I'm going to close this function over the closing parentheses, tap the Enter key, and we can see if we invest, starting with a balance of $10,000, $750 every month, and this could be a payroll deduction, and we keep this money invested or keep making those payroll deduction investments for 35 years, and our rate of return is expected to be about 4.5%. At the end of 35 years, we'll have a balance in our investment account of $811,471.79. And that is how you use the FV or future value function.